Hello, everyone. Thank you for joining this interview. This is an exclusive interview between Omdia and Intel to talk about Intel's strategy expansion into the robotics market, especially in the newer robotics segment. With me here is John Healy from Intel to talk about sort of Intel's plans and Intel's strategic partnership and their approach to this particular market with lots of excitement and sort of lots of things to look forward to. John, perhaps you can introduce yourself to the audience, and then we'll be keen to sort of hear more about your views on the upcoming plans and strategy from Intel.
Yeah, great to see you, LJ. I'm John Healy, and I run the industrial and robotics business within Intel, within our edge computing group. And I'm very excited about the movement in the market with respect to all things robotics, and really looking forward to the discussion.
Yeah, no, thank you, John. I think for the longest time, we always felt that the sort of Intel always has been a key part of the robotics and the industrial automation market. Intel has always been sort of a key player in the high performance edge computing solution and sort of a series of industrial automation solutions. I'm curious to see sort of how Intel would use all this capability that Intel has established in the past and translate that into successes in sort of like this new era of the robotics market, where you see the rise of new form factors like quadruped and humanoid robots.
Yeah, you're absolutely right. We have many years of experience and engagement directly with the robotics market, and I would say even more broadly with solutions of whereby automation is increasingly enabled at the edge. But maybe if we take a step back, and for robotics specifically, the market's really going through what I'll describe as an inflection. The world of robotics that was designed around primarily singular functions, primarily repetitive functions, primarily fixed location is really going through a pretty significant transformation. And it's a transformation to enabling multi-functional robots to deploy. Robots that can understand their environment more, that can perceive the environment they're operating in, and are increasingly benefiting from the application of AI to make them more capable, more multifunctional, but also more responsive to the needs of the environment and the applications that they're supporting. That's very exciting because it broadens out the opportunity for increased numbers of applications and much greater implications from those deployments across multiple different markets. But it comes with it some interesting complexities in terms of how those solutions can be developed and deployed. And that's really where we have applied ourselves to enabling the market to benefit from the opportunity, but to address some of those complexities and challenges by basing the solutions on the assets that we've been investing in.
Excellent response, John. I think I want to double click on sort of two major components that you have mentioned just now. So you kind of talk about robots going from single function to right now multiple functions, or perhaps multi-purpose robots. You also talk about robots moving from a fixed location and then more of a structured type of environment, now moving into a highly unstructured, sort of a highly dynamic environment where they have to actually collaborate with human workers and human being. Is sort of what are the sort of plans that Intel has to address those challenges? As you said, it's not just an AI challenge; it's largely also a computing challenge. And what are the trends that you are seeing in the market where Intel can address in an excellent way and can help developers to excel in their deployment?
Yeah, I think about it. If I think of a robot today, and particularly how it's evolving, it really breaks into two computing environments or halves of the way they operate. The first is the need to support for real-time control, an area where we've had a long history of supporting real-time, time deterministic control to ensure that the movement of the joints are safe, but they're also precise in timing. That's a very important aspect, and one where we've spent a lot of our time. And then, as I mentioned earlier, it's also then there's a second world, the world of perception, the ability for the robot to see the environment, to perceive that environment, to understand it, and to take action based on what it understands and what it determines. And that's, in a lot of cases, the domain of increasingly AI. So both of those worlds are now looking to coexist. They have traditionally been deployed or supported on two different computing environments, sometimes more than two, but certainly two, which could come from different vendors, oftentimes have different software stacks and how they're implemented, different tools for the configuration, implementation, and management of them. Where we've applied ourselves, LJ, is ensuring those worlds could come together, to increasingly converge those worlds so they can be consolidated into more singular computing platforms that are capable of performing both of those functions transparently, effectively, and efficiently, and at scale. So when we've invested in our hardware platforms, let's start there, with particularly our Core Ultra products, we've really focused ourselves on enabling the developers of robots to be capable of performing the real-time control effectively and efficiently, and integrating AI into the same platform so they can deliver much more cost effectively, but also more efficiently in how they can do their development work. So that's the first stage of the implementation. And then the second component is to ensure that they have the ability to build solutions through the software environment that we create to allow for in the scale and implementation of the application categories, irrespective of whether that's a fixed function robot, a mobile robot like an AMR, or indeed a humanoid.
Again, great response. I think so based on what you said just now, I learned two major things. So first thing is a single architecture, single platform. And then the second thing is obviously leveraging software, making it a lot more software defined. Could you deep dive a little bit on sort of how do you create that single hardware platform? And then how do you then enable that software element on top of it?
Yeah, so if you consider the Intel Core Ultra products, they are a combination of general purpose CPU cores and accelerator cores, like integrated graphics, to enable high performing AI. And so what that enables is a singular targeted platform for the developer of an application to consider implementations that they might have thought not possible or not possible cost effectively before. Now with the Core Ultra products, the developer of a robot, irrespective of the robot category, can bring their applications together and deploy them in a singular compute complex with a standard open set of tools and a increasingly open ecosystem of collaborators that they can work with across the market, across the industry. So that brings a number of benefits: a cost of implementation benefit, a reduction in complexity of implementation, and also a broadening base of vendors that they can work with for the subcomponentry that bring that robot together, which is in many ways a total cost of ownership improvement or advantage for the implementer. So very excited at the both addressing what I kind of consider the two primary challenges of building this next generation of robot: address the complexity of implementation and the cost of implementation. And we're looking to address both of those in a way that really unleashes a positive spiral of innovation across the market.
I think that's great news to hear, and I think what Intel has laid out here kind of gels with what the analysts and sort of the investor community felt with the current sort of the new future of robotics, where you are seeing, as you said, sort of our robots such as quadruped and sort of humanoid robots that now gets that sort of again unleashed into the human environment, is able to coexist with human and work very tightly and closely with the human workers. I'm quite curious on your view on all these new form factors, and then how sort of how these new form factors are being viewed within Intel, and then as well as sort of what's your, I guess, hope and aspiration when it comes to this new type of robots that we'll be seeing more and more in the market.
Yeah, it's a really good question, LJ. I think we consider it to be an evolution of the increased deployment of configurable rich AI at the edge. So if I think about the role we've played in edge computing over the last several years, we've considered that, a couple of things. The movement from more fixed functional hardware centric functionality to increasingly compute centric software defined functionality has increased and enabled value creation across multiple markets. That's really where we've applied ourselves over the last several years to enable the realization of increased insight, increased value creation across multiple markets because of the benefit of software-defined control, software-defined applications on an open standards computing edge infrastructure. robots are an excellent example of taking that almost to the next level.
Yes.
I think about it in terms of the robot being a manifestation of a software configured and controllable device that automates functionality, enables increased flexibility and value creation, and has utility in multiple different markets. In
Mhm.
many ways, a robot embodies AI at the edge. And so as we see it evolving through fixed robots that
Yes.
are fixed in location but highly
Hmm.
capable in terms of their the functionality, through to mobile categories, and
Hmm.
now towards, as you mentioned, quadrupeds or humanoids. It's really an evolution of the increased capability of what robots can provide as they're deployed in multiple environments. But
Yes.
you made another really interesting point, and very important point, is the coexistence of the robot with human workers or humans generally, depending on where they're deployed. Humanoids are a good example of that. And it introduces another, maybe two more really important characteristics that must be capable of being supported in the platform. We talked about real time control and precision, talked about the advanced capabilities in AI, but now we have the need for safety and the need for security. Both of those we've also applied ourselves to across multiple years of the solution categories we bring to the edge. Safety, functionally safe devices that can be certified to be capable of being deployed in environments where their behaviors need to be predictable and the outcomes of their operation need to be safe. That we support that within our platforms. And security by design in the implementation so that the device is secure, that the capabilities and the performance in the application can be preserved and supported in secure deployments. That will be increasingly important in devices, particularly those that are operating with humans.
No, you can't tell how happy I am when you sort of bring up the issues of functional safety when it comes to robotics. I think that has always been a critical issue, if not the issue number one when it comes to robotics deployment, whereby how do you ensure, as you said, so when robots work with human, they act safely, they act according to the regulatory compliance. I think nowadays, given the current form factor that we are seeing, those fixed location robots with assured sort of operational range, you can kind of impose, let's say, safety from both on hardware and sort of from a regulatory standpoint. But when the robot's now moving around and moving in a very dynamic environment, sort of safety becomes a critical issue. And it's good to hear that sort of Intel commitment to sort of the functional safety side of robots. If I may, to double click on that issue as well, like is there a way, is there sort of, aside from, let's say, the sort of open standards that Intel are embracing, as well as being able to secure the data and the motor controls that goes into the robotics operation, is there is are there any other sort of approach that Intels are taking when it comes to robotic safety? And do you sort of also see that standards and regulatory requirements become a lot more important moving forward with the increased number of robots?
So it's a great question, and what we apply ourselves to is addressing a number of things. The technical capability of the platform. We'll speak a bit about the software that we are investing in, particularly for robots, to make that true, and then ensuring that we're enabling innovation at scale in the market through the partnerships that we look to foster across our ecosystem. Because the points you make are really important. Some of the evolution, particularly in robotics, is still occurring. The implementations, the standard that, and the standards that will govern those implementations, the criteria by which the deployments will be judged or regulated or certified, all of that is continuing to evolve. And we apply ourselves to ensuring that we're enabling that innovation and that evolution to occur at scale by embracing maybe two approaches. The first is both the investment in the hardware, and I spoke to that in terms of our investments in the core ultra processors, but also across the breadth of our product portfolio. The second is the investments we make in the software to unleash those capabilities. Very recently, we announced our Intel Robotics AI Suite, which is a continuation of a set of edge AI suites that we have been curating and delivering to market across each of the edge markets that we service, manufacturing to retail and to core infrastructure in the metro infrastructure for the cities. Think of the Robotics AI Suite then as being a combination of a number of things. It is a set of reference applications to show the capabilities like perception and locomotion and motion control that we spoke about earlier, imitation learning to train a robot model to perform well, the pipelines of applications like streaming media to ensure that we can support fixed function robot or fixed location robots, AMRs, and humanoids to be deployed. And then algorithms that show generative AI, vision-based AI for application categories. But within that software approach is a set of modularized building blocks that allow our industry partners to curate and build solutions around, but also to contribute to as they evolve the applications they bring to market. So if you think of the evolution of safety, the evolution of security,
Yes.
the evolution of the application categories, we want to foster a burgeoning and vibrant ecosystem around these assets. So as we contribute them to the ecosystem, they can build, evolve, and adapt them. So those continual evolutions then of the standards, the evolutions of how the applications will be deployed are being fulfilled and enabled. And it's a virtuous cycle of innovation between the investments we make and what we enable and what our partners build and bring to market. And it doesn't constrain the ability for the market to evolve and to grow and to develop in the direction that it needs to evolve in.
No, awesome. And I'm really glad to hear you bringing up the Intel Robotics AI Suite, because it won't be a proper conversation in 2025 without mentioning AI. I think you kind of mentioned a little bit earlier on where robotics is this representation of physical manifestation of rich AI or rich edge AI. I do wonder, I think, in your opinion as well, sort of because of the requirement on functional safety, because of the deterministic nature of our industrial automation requirement. How do you see the dynamic between AI models being deployed at the edge? Do you see a combination of, let's say, generative AI models or rather foundation models with rule-based engine, or you start to see sort of smaller language models being deployed or sort of smaller foundation models being deployed? How do you see that transition from traditionally very rule-based model control to now perhaps being governed by sort of this system one, system two approach within humanoid robots, where you're leveraging a lot of the virtual language, vision language models or vision language action models?
Yeah, we see that exactly as you described it. That it is that evolution that robot implementations can move from more, pre-configured, pre-trained models for more structured environments, which is what we've seen happen in many applications today, to more the ability to be more adaptive to unstructured environments and to increasingly be capable of supporting the vision language action that you describe in VLA models. And so our approach has been to enable that set of that flexibility to be implemented across our market. So the investments in the Robotics AI Suite is exactly to enable that to occur. And as it continues to evolve, we will continue to evolve the advanced AI algorithms in line with the application categories, consider the pipelines for each of the different robot categories, and continue to invest in reference applications that show the art of what's possible to each of those markets, so that evolution, as you described, can be fulfilled. And what we're very excited about is that the investments in the hardware that continually support that in very efficient and cost-effective and performant ways continues to evolve as the software continues to unleash that value and that capability. But we absolutely see the need to be capable of supporting that evolution to occur, whilst also not compromising the real-time deterministic control, the safety of the implementation, and the security required in the deployment.
Awesome. I do have one final question before I let you go, John. I'm aware of the time. Intel success in the past has always been based on long-term partnership with, as you mentioned earlier, sort of the key players in the market, including the system integrators, the ISVs, and sort of all the equipment and sensor partners that you have in the industrial automation system. Could you elaborate maybe a bit more on sort of how Intel is going to approach this in this, I guess, quote unquote, new era of robotics, where you are seeing a lot more complex robotics form factors, and where sort of those partnerships can enrich Intel strategy in sort of enabling developers in this market?
Yeah, you're absolutely right. Our philosophy and approach has always been from the beginning to engage with and work with a growing number of partners in an open ecosystem. Our go-to-market approach is to ensure we're engaging with a broad base of partners, ODMs and OEMs, ISVs and OSVs on the software side, as you mentioned, system integrators, to ensure that there's a strong support of collaborators targeting applications that run on our architecture on x86. That is as true in robotics as it has been in all of the other markets we service, particularly across the edge. And that global hardware and software partner ensures integration of solutions that can target our underlying platforms, but it also ensures, as we bring AI reference implementations for those platforms to market, they have the ability to work with us to qualify the performance or the implementation of those platforms, so that then the application categories that the ISVs bring have known good targets to deploy their applications against. That's the first part of it. The second, though, is that by bringing assets like the Robotics AI Suite to market, it also allows us to continue to contribute on a regular beat rate. We intend quarterly releases to GitHub of those capabilities, but for our partner base to contribute their assets as well, to create an ongoing spiral of positive innovation as new assets and new capabilities are brought to market in support of those. And so we see continued engagement across our partner base. They're enthusiastically receiving what we're doing because it enables them to bring new categories of application for robotics to market in ways that they may not have been capable of doing before. Because we're reducing the cost of implementation, we're hoping and helping to reduce the complexity of implementation. But for the consumer of the robot, we're broadening out the scale of choice that they have in terms of how those robots can be developed and delivered and deployed at scale. That's a very important part if we want to really address the cost component from what might be more constrained, more restricted implementations today that imply more costs, and ensure that we can deliver at scale at a lower total cost of ownership that drives for more efficiency and to more effectiveness in the long-term deployments. Core to that, as you mentioned, is our investment with and continued support of a very broad and open ecosystem to make it true. We're excited about what we're seeing.
No, I'm equally excited as well, John. I think based on just your last statement alone, I do see a very bright future of Intel in the robotic space, and I'm sure sort of Intel will do really well moving forward because sort of the market itself is hungry for a strong solution and sort of a strong partner like Intel. With that, I'm wrapping up this interview. Thank you, John, for joining the call. Appreciate this opportunity to get to speak to you and to get your insights on Intel's strategy in the robotics automation market, and appreciate your time.
Great, LJ. Great to meet you, and appreciate your time also.